Welcome to Study Loop.
We're told that a stone is suspended from a pulley, from a wire that's wrapped around a pulley. And so then the pulley is uniform disc with mass 10 kilograms and a radius of 30 centimeters. And we're told that you measure that the stone travels 12.6 meters in the first 3 seconds starting from rest. And we want to find the mass of the stone and the tension in the wire. I didn't actually find the tension in the wire. We'll do that on the fly then, which shouldn't be hard. So let's see here. We know that from free body diagram of the stone, the weight of the stone, and I'm going to say positive is down. The weight of the stone minus the tension equals the mass times the acceleration of the stone. You also know, because we're assuming that there's no slipping here, that this acceleration is just the tangential acceleration of the disk, which is the radius times the angular acceleration of the disk. So this gives us, solving for t, we get t equals m2g minus a, or m2g minus r alpha. Now doing a moment balance on the pulley here, about the center here, so that these reaction forces and the weight all drop out, we get t times r is the torque equals j alpha. J is 1/2 m1 r squared. M1 is the mass of this. M2 is the mass of the rock. That means that if we take, let's see here, we can plug this into here, this expression into here, and then we get an r that cancels out, so we get m2 g minus r alpha equals 1/2 m1 r alpha. Now we know that we're told that it went 12.6 meters in the first what was it, seconds? 3 seconds, and it started from rest. So this is actually 0, and we get that then if we solve for a, we know t and we know y, and a winds up being 2.8 meters per second squared, and that's obviously in the plus direction, so that's down. So here we can solve for m2. So m2 is m1 over 2 times the quantity a divided by g minus a, and we get that is about 2 kilograms. So now we need to find the tension. So let's see, the tension we know is m2 g minus a, and that's 2 kilograms. That's 9.81 meters per second squared minus 2.8 meters per second squared, and let's do that math. And our little scratch pad here, 2.0 times 9.81 minus 2.80, and that is, let's get it into decimals, is about 14 newtons. So there we go. That's the tension in the cable here. Is 14 newtons.